Hi, I'm John Sewell. I'm doing this video as part of an educational neuroscience master's degree with the University of Central Queensland. This is part of the course Neuroplasticians Research Project. We understand that the brain changes in everything that we do in a classroom as the learning process continues. This should be fundamental for all teachers in their preparation and in their delivery of lessons. For this to happen, there's a number of things that teachers need to do. Because we understand that the brain changes and that the brain is plastic in everything that happens in life, but also in a classroom, there's a number of things that teachers fundamentally ought to be, which are listed here. I'm going to deal with each of those things in the following slides. Because the brain is plastic, every activity that is participated in a classroom changes the brain. These brain changes involve neural pathway changes in structure, function, and organisation in response to the activities that we provide. Educational activities either strengthen or weaken neuronal connections. As teachers engage different parts of the brain, those different parts tend to be strengthened together. And that reinforces the idea of neurons that fire together, wire together. Understanding how plasticity occurs is important both for teachers and students. The brain creates new neuronal pathways or strengthens existing ones as we learn. Learning is a major cause of neural networks forming as synapses strengthen as learning occurs. There is a definite negative to plasticity though. Detrimental changes are also plastic, so can lead to negative results. We've all seen in classrooms where students disengage from our activities. That disengagement causes some deterioration in the networks in the brain. The brain changes whether we choose to learn and engage or whether we choose not to learn and disengage. A key to successful learning is the student's intention to learn. It's important for students' intention to learn that they have a growth mindset. For students to have a growth mindset, teachers also need to have a personal growth mindset and teach their students to have that growth mindset. If a teacher has a personal fixed mindset, they will be unlikely to have an understanding of the benefits of students having a growth mindset. If students have a growth mindset, they will be able to understand that the brain changes with every cognitive activity participated in, and with use the brain grows. This makes all tasks important. The use it or lose it principle is very real to students when they become aware of how their brain works. I think it's very important for teachers to focus on how students learn as well as on how they teach. Lessons on the fact that learning changes the structure and function of the brain can engage students very effectively, especially when that's combined with explicit instruction on the use of cognitive and metacognitive strategies that will make them better learners. Explicitly teaching students about neuroplasticity also has a transformative impact on the classroom. That's because students have an awareness then that everything they do impacts on their learning. Education about neuroscience and neuroplasticity alone in a classroom can bring about improvements in learning outcomes. It's also important to understand that we learn better with social cues. The brain is fundamentally a social organ, and if we engage students in social activities, then that will benefit their cognitive processing. It's good for teachers to focus on learning how students learn rather than on teaching. Knowing how students learn means understanding how the brain works. Teachers need to know how to make students recall what they've experienced in lessons. That is what makes the learning permanent. With a focus on learning, it's important to know that initial changes are just temporary. Where the brain judges an experience to be interesting or novel, or if the behavioural outcome is good, then changes become permanent. Hutton suggested that creating brain-based lesson plans allows for optimal learning experiences for students. So those lesson plans will involve novelty and interest. Concepts transferring into long-term memory is obviously essential for good learning. As students are aware that the brain develops with every cognitive activity, that makes all tasks important, and with use the brain grows. This knowledge will very often cause students to adopt a growth mindset, which immediately makes them metacognitively aware as well. One of the things I find my students get very interested in is an understanding of some of the basic fundamentals of the brain. The hippocampus is one of those regions that is heavily associated with memory, emotion, and learning. It's a very important part of transferring things from working memory into long-term memory. It's also one of the two areas of the brain where neurogenesis, or the formation of new brain cells, occurs throughout life. The hippocampus takes sensory inputs and integrates them with patterns from pre-existing memories, thereby binding the information from new sensory input into storable patterns of relational memories. In other words, it makes use of pre-existing concepts. Making associations with what the person already knows is one of the main ways of processing from working memory into long-term memory. Teachers should be very careful about judging students' ability, potential, and intelligence. If the brain grows, as we've already established, then every activity is important, and the neuroplasticity of the brain will often determine the learning of an individual. Neurogenesis is a continual process throughout life, particularly in adolescence. Because plasticity is a core concept, it should be foundational to the understanding of learning and development. Differential rates of development of the teenage brain should be well noted, and because of that, every activity is important, and the brain grows with every activity, so judgment of students' potential should be very warily considered. Because neuroplasticity is such an important part of learning, then teachers ought to teach about it. Therefore, they should be neuroeducators. They should teach students about the brain. They should teach about neuroscience and neuroplasticity, because these understandings alone can help students improve. They ought to teach students about the negative effect of negative emotions such as fear or stress, and there oughtn't be fear and stress in a classroom. As teachers embrace the fact that the brain is primarily a social organ, then social activity should be a major part of all lessons. And knowledge about one's own processing information and strategies that one uses are really important for teachers to teach students. Teachers should teach about the brain because as students get greater awareness of how they acquire knowledge and learn to regulate their behaviour to optimise learning happens, they begin to see how much their strengths and weaknesses affect how they perform. The ability to think about one's own learning and thinking is what neuroscientists call metacognition. So being metacognitively aware is really important. Because there's an emphasis happening on education and neuroscience, there are a lot of neuromyths around. Neuromyths are partial truths, overgeneralizations of scientific findings, for example, exaggerations, misinterpretations of findings and data, and misconceptions and unsubstantiated beliefs. Here are some neuromyths that are commonly believed. I've heard this a lot in schools I've been at. Listening to classical music increases reasoning ability. A primary indicator of dyslexia is seeing letters backwards. Individuals learn better when they receive information in their preferred learning style. That's certainly been a major understanding in schools. Some of us are left-brained and some of us are right-brained due to hemispheric dominance, and this helps explain differences in how we learn. I've certainly been told at times, being a science teacher, that I'm left-brained and not right-brained. The other one is we only use 10% of our brain. That is often attributed to Einstein. I'm not too sure whether he really said it or whether that's a myth. These beliefs become a problem if they're harmful to students' learning. Here are some of the harmful neuromyths. Boys' and girls' brains have a different potential to learn. That can be very dangerous. People learn better when taught in their preferred learning style. Different races are better at different skills. There are critical periods for learning specific academic areas. E.g., you learn languages better when you're young and you can't learn them so effectively when you're old. The teens' frontal lobes are not yet fully developed. The trouble with harmful neuromyths is that if teachers and students get distracted by those beliefs, then they end up failing to focus on important things that result in good learning. Thank you. That's the end of this presentation. I hope it's been useful.